Welcome to the DIY Honda Garage channel. DTC P0340 indicates a malfunction related to the Camshaft Position CMP Sensor A in Honda Civic models from 2011 to 2015. The CMP sensor plays a crucial role in the engine management system by monitoring the position of the camshaft, which helps the Engine Control Module, ECM, manage fuel injection and ignition timing. When this sensor fails or sends no signal, it can lead to poor engine performance, increased emissions, or even engine stalling. This Diagnostic Trouble Code will prompt the vehicle's onboard diagnostic system to record the fault, preventing optimal engine operation. Addressing this issue promptly through a structured troubleshooting procedure is essential for restoring the vehicle to its proper functioning condition. The Camshaft Position CMP Sensor A is a critical component that measures the angular position of the camshaft. It sends this information to the Engine Control Module, ECM, which uses it to adjust the timing of fuel injection and ignition, ensuring optimal engine performance. In the Honda Civic 2011 to 2015 models, this sensor is typically located near the camshaft assembly, making it accessible for inspection and testing. If the CMP sensor fails or the signal to the ECM is disrupted, the vehicle may exhibit symptoms such as rough idling, hard starting, or reduced engine efficiency. Thus, understanding the sensor's function and location is crucial for effective troubleshooting. Several factors can lead to DTC P0340. An open circuit in the wiring, particularly in the IG1 cam line, can disrupt the signal from the CMP sensor to the ECM. Additionally, a faulty CMP sensor itself may not produce any signal, leading to this code being triggered. Loose connections and terminals at either the CMP sensor or the ECM can cause intermittent failures, making it important to check these connections thoroughly. Each of these potential issues must be investigated during troubleshooting to ensure that the root cause of the malfunction is accurately identified and addressed. When DTC P0340 is active, drivers may experience several symptoms reflecting the sensor issue. Rough engine idle is a common symptom, as the ECM struggles to accurately manage fuel injection timing without proper camshaft position data. Furthermore, difficulty starting the engine can occur. The engine may crank longer before starting or may not start at all. Reduced engine performance, including sluggish acceleration and poor fuel economy, may also arise due to improper management of the ignition and fuel systems. If these symptoms are observed, an immediate diagnostic check using the HDS is recommended for accurate identification and corrective action. The first troubleshooting step involves verifying the issue by ensuring the ignition switch is turned to the on second position. After this, it's essential to clear the existing DTC using the Honda Diagnostic System, HDS, which allows the system to reset the fault codes. The vehicle should then be started to see if the issue persists, and the HDS should be used once more to check for any pending or confirmed DTCs. If DTC P0335 is indicated, it confirms that the issue still exists, allowing the technician to proceed to the next step in the troubleshooting process. If not, this suggests that the failure may be intermittent, prompting the need to examine the connections and wiring for any loose terminals or poor connections. Step 2 of the troubleshooting process begins by turning the ignition switch to the lock 0 position to ensure safety during the operation. The next action is to disconnect the CMP sensor A3P connector to prepare for voltage measurement. The ignition is then turned back to the on 2 position, and it's crucial to measure the voltage between test points 1 and 2. Test point 1 is defined as the CMP sensor A3P connector, number 1, white, while test point 2 is connected to body ground. If battery voltage is present, it indicates that the IG1 cam wire is functioning correctly, thereby allowing you to proceed to the next step in verifying the system integrity. If there is no battery voltage, it signals an open circuit in the IG1 cam wire, necessitating repairs to restore proper function. In troubleshooting step 3, the focus is again on measuring voltage, this time between different test points. With the ignition still in the on/to position and the CMP sensor A3P connector disconnected, voltage is measured between test points 1 and 2, where test point 1 is CMP sensor A3P connector number 3, blue, and test point 2 is body ground. If the measured voltage is around 5.0 volts, it implies that the cam wire is functioning correctly, allowing you to proceed to the next step. Conversely, if the voltage is not as expected, it indicates an issue with the cam wire, prompting a detailed examination for faults in that line. Addressing any found issues in this area is critical before moving forward. Step 4 involves another voltage measurement procedure, focusing on the LG2 line. You will measure voltage between test points 1 and 2 with the CMP sensor A3P connector still disconnected and the ignition in the on/to position. Test point 1 includes CMP sensor A3P connector number 1, white, and test point 2 pertains to CMP sensor A3P connector number 2, brown. If battery voltage is detected at these points, it means the LG2 wire is functioning properly, and the next step would be to replace CMP sensor A itself, since the issue lies with that component. However, if there's no battery voltage, it indicates a fault in the LG2 wire that necessitates an open repair between CMP sensor A and ground point G101. In troubleshooting step 5, the approach shifts to checking for shorted wires within the cam line. Begin by turning the ignition switch to the lock 0 position for safety, and then use the HDS to jump the SCS line. Follow this by disconnecting the ECM connector C, 49P. Continuity must be checked between test points 1 and 2, where test point 1 refers to ECM connector C, 49P, number 16, blue, and test point 2 is connected to body ground. If continuity is present, it suggests a short in the cam wire between the ECM and CMP sensor A, which needs repair. If continuity is absent, it indicates that the cam wire is not shorted, allowing for further investigation into the system's integrity. The final troubleshooting step focuses on verifying continuity of the cam wire once more. With the ignition switched to lock 0 and having disconnected the CMP sensor A3P and ECM connectors, check for continuity between test points 1 and 2. Test point 1 is defined as ECM connector C, 49P, number 16, blue, and test point 2 is CMP sensor A3P connector, number 3, blue. Establishing continuity here indicates that the cam wire is functioning correctly. If this is the case, the next step would involve updating the ECM software or substituting it with a known good unit to ensure proper functionality. However, should continuity not be present, it signals an additional open issue in the cam wire that requires immediate resolution before concluding the troubleshooting process. After all repair steps have been completed, the final verification process must ensure that everything is restored correctly. Start by turning the ignition to the lock 0 position before reconnecting all the connectors that were previously disconnected. Once everything is reconnected, set the ignition to the on to position and use the HDS to reset the ECM, which helps to clear any old fault codes and prepares the system for fresh diagnostics. Following this, it's essential to conduct the ECM idle learn procedure to ensure the system recalibrates itself for optimal engine performance. Finally, check for any pending or confirmed DTCs using HDS to confirm that DTC P0340 is no longer indicated. If it still appears, additional checks for connection issues at CMP Sensor A and the ECM are necessary to prevent future occurrences of DTC P0340. Implementing a proactive maintenance routine is advisable. Regularly checking the electrical connectors, particularly at the CMP Sensor A and ECM, ensures that no loose or corroded connections could cause intermittent failures. Additionally, it is vital to inspect the integrity of the wiring connected to the CMP sensor and ECM, ensuring that no fraying, breaks, or shorts are present. Updating the ECM software regularly can also help in addressing existing bugs and improving software performance, which may aid in reducing fault code occurrences. Taking these preventive measures can significantly enhance the reliability of the vehicle's engine management system. In conclusion, the DTC P0340 points to a significant issue with the Camshaft Position Sensor A, which plays a crucial role in the engine management system of the Honda Civic from 2011 to 2015. Thorough troubleshooting is essential to accurately diagnose the underlying problems, whether they relate to the sensor itself, the wiring, or connections to the ECM. Each step must be carefully executed to identify faults and implement repairs correctly to ensure optimal vehicle performance. Furthermore, adopting routine maintenance practices can serve as a first line of defense against issues like DTC P0340 occurring again in the future. Such diligence not only contributes to reliable vehicle operation, but also enhances overall driver satisfaction. Please like and subscribe to the channel. See you next time.